guys, welcome to Mosfet lecture series. I hope whatever the content that I am delivering so far you all understood and you might got almost 70% of the idea how to proceed with the Mosfet DC analysis. Whatever the things that I have delivered so far all are DC analysis only, and I have also told you AC analysis means we will be focusing on AC source voltage. See here, whatever the voltage that I have considered so far all are DC parameters, DC voltage. So in AC we will be calculating gain, voltage gain, current gain, input impedance, output impedance. So that analysis will be completely different. Anyway, things whatever that I have delivered so far, that will be only DC, and if you do understand everything properly, you will be able to solve all the questions. So if you are really understanding the things, then don't forget to click that like button. Kindly share it with all your friends. Okay. So let us continue the lecture. In this lecture, let us try to solve this question. Given it is, when the value of VD1, focus on the question clearly, they given that the value of VD1 is equal to 1.6 voltage and its correspondent drain to source current is 0.5 milliampere. Second case, suppose if the value of VD2, that is the value of VD is increased to 2 voltage from 1.6 to 2 voltage, they are raising it. Then what is the new value of the drain to source current? That is the question. Whereas the threshold voltage of the MOSFET is fixed as 0.8 voltage. So basically now the first thing what you have to observe here is VDD and VD both are not same. You know VDD is the supply voltage, it is fixed here. It is clearly indicated in the question. VD means voltage across the drain terminal. So here we are going to fix the value of VD. And one more thing is, tell me what is the region of operation. Whenever you are observing that gate and drain terminals are shorted together, immediately you have to say that the region of operation is saturation, sir. So you know the region of operation is saturation. Once your MOSFET is being operated in the saturation region, then you know the expression for current. Actually they are talking about current only, right? So let me first write down the expression for current, later we will try to bring the answer. So the value of drain current can be written as mu n C ox omega by L. Of course there is one more parameter that is called 2 into, we can also further write VGS minus VT whole power 2. Now if you observe the question clearly, they have not given any data about this mu n Cx omega by L. So you can just keep it as it is. Now let us proceed further. Case number 1, I am calling it as ID1. Correspondent, the thing is, which is varying here, the value of VD. VD only they are varying. VD variable means the value of VGS also going to be changed. We have to bring the relation between VGS, VDS like what we did in the previous question. Same kind of relation. So if I will write the expression for ID2, then how will you write the expression? ID2 is going to be mu n C ox by 2 omega by L into, in bracket this can be written as VGS 2 minus VT whole square. Now we have to bring the relation between VGS and VD, because the question is when they are changing the value of VD, what is the new value of ID? So it is very important to bring the relation between VD in order to solve this question. Let us observe the question first. Calculate the value of Vs. If you observe Vs, sir, it is grounded. So the value of source voltage is obviously equal to 0 only. First conclusion. Second, VD and from here if you observe the value of VD and the value of VG both are same. Why? Because they are shorted together. Okay, sir. Now tell me, how will you express the value of VGS? So case number 1. So let us write general. In general, VGS can be written as VG minus Vs. Similarly, VDS can be written as VD minus Vs. Since the value of Vs is equal to 0, if I will substitute that value here, this both will become 0. So the resultant, this can be written as VG, this can be written as VD, and one more thing, if you observe carefully, since VD and VG both are same only, so in place of VG you can replace it by VD. So the conclusion is VDS equal to VD, VGS also equal to VD only. So finally what we understood, in place of VGS directly you can consider VD. So this expression, this VGS1 can be replaced by VD1, VGS2 can be replaced by VD2. That's all, because both are same. Now if I will take the ratio between ID2 upon ID1, can you please tell me what will come? The thing is, when the moment you are trying to take the ratio between these two expressions, the common terms will get cancelled. Mu n c ox by 2, mu n c ox by 2, omega w by l, all these factors will get cancelled because they are common to each other. So the conclusion is the resultant parameter, only thing what will exist here is Vd2 minus Vt whole power 2 upon Vd1 minus Vt whole power 2. Only these things will exist. Remaining parameters, this all will get cancelled. See, these both are same. When you are taking the ratio, they will get cancelled automatically. Fine, sir. So let us substitute the values. They clearly told that in the question what they given, Vd2 is 2, Vd1 is 1.6, ID1 is 0.5 milliampere. Substitute all the value. Vt also given. Vt is given as 0.8. So if I will substitute all the values, so from here further I can write the value of drain current in the second case is equal to drain current in the first case into, in bracket it can be written as Vd2 minus Vt upon Vd1 minus Vt whole square. We can write combinedly because both are in square only. So I can group them together. So ID1 is 0.5 into 10 power minus 3 in bracket Vd2 2 minus 0.8 upon case number 1 1.6 minus 0.8 whole square. What you will be getting? So by solving this expression you will be getting 0.5 into 10 power minus 3. So this value will become 2 minus 0.8 means it will be 1.2. 1 minus 1.6 minus 0.8 means it will be 0.8 whole square. So see there, if I will cancel it, in order to cancel, if you cancel 1.2 by 0.8, it will become what? You can cancel it by 4. 3 times of 4 will be 1.2, 2 times of 4 will be 0.8. So 3 by 2. 3 by 2 whole square will become 9 by 4. So finally what we got here? 0.5 into 9 by 4 into 10 power minus 3. Can you reduce it further? Of course, sir. So this can be, see, 0.5 can be written as 1 by 2. So it will become 9 by 8 into 10 power minus 3. Further, I can cancel it. See there, it will become 1 point, again 1, 2, 5, 10 power minus 3 means milliampere. That is the new current. See, the thing is, if you observe, since the first lecture of the Mosfet, I am not using anything new. The only thing is I am using drain current and I am bringing the relation between gate to source voltage, drain to source voltage. I am trying to analyze the whole question only with this data. It doesn't matter whatever the question. 95% of the questions can be directly solved only with the help of this data. This will be sufficient. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.